Do you recognize any of these patterns? Where have you seen them? What do you think inspired these patterns? Nature is beautiful and has inspired many designs to create extraordinary inventions. Nature's beautiful elements have also prompted mathematicians to observe and analyze the presence of geometric features. Take plants for instance. The branching structures, the leaves, and the blooming flowers have really unique arrangements. Let's look closely at these natural structures. We will recognize that some elements have been repeated in special arrangements to form these patterns as if nature has its own kind of code. Can we mimic these patterns by giving step-by-step instructions to a computer? Biomimicry is a practice of seeking inspiration from nature and mimicking various processes and patterns in nature to solve complex problems. Let's begin by exploring a tree as an example. Trees are what mathematicians call self-similar shapes. You see, the trunk has branches, and then these branches diverge into smaller branches, which form even smaller subsequent branches, branches upon branches after branches. This process repeats many times until we arrive at a super small region that may not be able to be divided any further. If we look closely, the shape of smaller branches resembles the shape of bigger branches that indeed look similar to the whole tree itself. One part resembles the whole. This property is called self-similarity. A pattern with a defined set of rules is copied again and again on multiple levels with only incremental changes between levels. How can we replicate this tree-like pattern by making self-similar shapes? This process of drawing self-similar images repeatedly is what we call recursion. So let's begin with a simple set of instructions. Draw the letter Y. Now draw two smaller Ys from the endpoint of each branch, changing the direction. Now repeat again, and one more time. We will need to give even more specific instructions to a computer in a language that it really understands. Using recursion, let's now try programming tree-like self-similar structures. We will use a browser-based version of the processing programming language. So let's go to a web browser and just type in openprocessing.org. Open Processing not only lets you create your own visual drawings, but also allows you to build on other people's ideas. If this is your first time, we really recommend you start learning by remixing a project designed by the processing community. You can begin typing recursive tree in the search bar, and you will find multiple projects designed by community members. Choose a project that you like and click on that project. Once the project opens, you will see three buttons on top. The I button describes the project. The play button allows you to run the code and see the visual drawing. The code reruns each time you press the button. Clicking the third button allows you to see the code. You can make changes to the code. Try making small changes by modifying the code and clicking on the play button after making these changes. Start with maybe changing one thing at a time. This will enable you to see the impact of your modifications on the final design. As you make these changes, you will explore the purpose of each line of code. You can label what it means by using the comment feature. Simply use 2 forward slashes to take notes in your own language. These notes are for your own references and won't interfere with your program. Understanding the code. Just like learning a new verbal language, learning a new computer language can sometimes be tricky and frustrating. Sometimes you may find terms that are confusing or do not make sense at all. You can dig deeper and research what it means. The Open Processing language is built using P5JS. You can go to their website, p5js.org, and click on the References section to learn more about the commands that you are using. If you don't understand a command, copy the command and search it in the References section. Sometimes your code may work, other times it won't, but that's okay. You can always undo your edits and go back to the original code. This is all part of the tinkering and really the learning process. When you feel satisfied with your design, you can save the project as a fork to the original code. You will need to create an account to save your code. Happy coding! And we really hope you will explore different variations of diverse patterns in nature. What pattern will you mimic next?